Hi guys, Buildzoid here, and today we're going to be taking a look at the lovely card in front of us. This is a ASUS Matrix R9 290X. So this is a real Matrix card, unlike the 2080 Ti Matrix that's going to be coming out. That was announced recently, because this is actually targeted at extreme overclocking and has like a relatively reasonable, reasonable air cooler. It's not, the best heatsink ever designed. Whereas the new Matrix is a Strix with an AIO strapped to it. In my opinion, significant downgrade for the Matrix brand as far as, the cards goes. So, we will be taking it apart. I've not modified the card in any way yet. There are mods planned for it just because, well, we kind of have to do a bunch of things. But before we start tearing it apart, let's just highlight some of the things that are visible from, visible with the card still assembled. So, let's zoom in. Man, it is nice to have a proper camera. Okay, so, there we go. So ASUS still has these. These are like little Vault mod points. So, you have like vCore, you have memory, and the last one should be VDDCI. So that would be the memory controller voltage. We have some over here, we have some extreme overclocking features, which they're a bit of a... okay, I'm not going to get that into the shot. Okay, well, whatever. We have these pads right here, which I'm not sure which ones of them do what, and there's several of them around the card. There's also over there. So, yeah, there's also these. And I'm not sure which ones do what. So, normally ASUS cards, like a lot of ASUS cards come with these, and essentially they do things like enable LN2 mode. On this card, they also enable the memory heating system, and then there's like, the problem is there's 3 of these pads, and I've just named 2 things. So you can see how I'm like, okay, well, I'm not entirely sure what all of them do, and unfortunately, I can't find so for a lot of other ASUS cards, if you, Matrix ASUS cards, you can actually find like you used to be able to find some very detailed extreme overclocking guides, which would tell you, okay, like you short that, you short this, you do this, these kinds of voltages for, this temperature range, you should hit these kinds of clocks. Because ASUS used to basically, like, you have that for, like, the 7970 Matrix, the 7970 Direct CU2, the 780 Ti Matrix. So, like, there's a bunch of Matrix cards where you just have all of the details, and this one, for some reason, doesn't really have any of that, which is kind of unfortunate, because it is still it's still a beast of a card. And it has a lot more than just what we can see here. There's a bunch of software features that it comes with as well. And also on this edge, we have some, extreme overclocking functions. So that's a Molex power connector for the memory heating system. So the idea behind that is that some memory chips don't like being too cold, so that solves that. And then we have this safe mode button, which... apparently that puts the BIOS completely back to stock, or like puts the card back to stock. I'm not entirely sure. Actually, I think that's probably for GPU tweak being retarded. So if you're not aware of this, GPU tweak is like ASUS's overclocking software. It's by far the worst GPU overclocking software out there. Like, it doesn't get worse than GPU tweak. Unfortunately, with this card, you kind of have to use it because there's a whole bunch of features that GPU tweak has with this card that nothing else does. But working with GPU tweak on any AMD GPU is pretty much synonymous with having to go into safe mode every so often and editing the registry, because GPU tweak just decides to black screen on driver initialization because GPU does that. GPU tweak does that. So yeah, I've already dealt with that several times with this card. Far back enough before I knew you could get around, actually I only figured out like the registry based fixed relatively recently. In the past, I would actually just have to reinstall the drivers because that was the only way to get GPU tweak to wipe its profiles. Because essentially the problem is that GPU tweak would save a bunch of settings which were unstable, and you'd get into Windows, it would load those settings up, and it would crash the card. And you'd be screwed. So, yeah. And GPU tweak still does that. It's just that, it's easier to get, well, I figured out how to get around it without having to reinstall the drivers. Not that that's all that different, that's a whole lot more convenient, but yeah, it's just awful software. Anyway, let's take this thing apart. And right now, as you can probably tell, this isn't Cryonaut. Cryonaut is a much paler thermal paste than this. This is actually the Corsair thermal paste that I have a bunch of now because, yeah, I'm trying to conserve the Cryonaut. Also because the Cryonaut has a tendency to put gouges into dies, and that connector does not want to let go. Come on, there we go. I hate these. But that connector is for this right here, and that is not well, it is RGB, but that is actually a load indicator. It's not like an aesthetics thing. So this changes color based on how much GPU load, how much load is on the GPU. As far as I'm concerned, that's not all that useful. So, yeah, but it does exist. So there we go. Here we have the card. And of course we have a dedicated VRM heatsink, which is a little bit on the anemic side, but you know, if you're on the stock air cooler, then that's not an issue. And if you're benching on LN2, well, you'll have a fan over this section of the card anyway. So let's pull that off. And like it has a decent amount. Well, given its size, it has a good amount of surface area. It's just really not that big. So that's kind of that. But it's mostly so that it clears the heatsink that the card comes with. Also, yeah, I guess it's worth, you know, mentioning this. The heatsink does have like this is one of those direct contact heat pipe heatsinks from ASUS. And I've seen a lot of people talk about how this is stupid because like you won't get proper thermal transfer to the heat pipes on the outer edge. But the thing is, in my experience with like other DirectCU2 cards, because I've not really had that many of them, if you have a DirectCU2 card from a card from ASUS that uses DirectCU cooling, and it doesn't do very well in terms of temperatures, it's not the heat pipes, it's the thermal paste. Because I had a RX 480 Strix. You swapped the thermal paste and it dropped like 15 degrees. And this card, I've never even run it on stock thermal paste. I don't know how it does on stock thermal paste, but with the Corsair thermal paste on there right now, it actually it's not, as far as I can tell, it's not that much worse than any other R9 290Xs I used before. And I used you know, 3-fan what was it, Gigabyte Wind Force cards, which don't they have a contact plate. They don't have heat pipes like this. So yeah, and the thing is, like, I think a lot of people don't well, the thing about heat pipes you have to understand is that heat pipes will transfer heat in any direction. There's nothing saying that this heat pipe right here, well, this heat pipe right here, which has contact to the die, right, that this heat pipe can't transfer heat that way, right? It can do that. It can do that just fine. Obviously, it might not be as optimal as if you had maybe a metal plate in there, but like, I don't think this is as bad as a lot of people think it is. I think most of it comes down to that, just the mount, like the thermal paste application being just garbage, or the mounting pressure being garbage, because like this seems to work fine. And I do know that there's like a lot of reviews out there where this card does awfully on temperatures. And I think my RX 480 Strix was the same kind, like the same style of heatsink. And before I redid the thermal paste, the temperatures were freaking terrible. So yeah, I don't think this is inherently an issue, because like heat pipes transfer heat to their sidewall. If they didn't, then, you know, this wouldn't work, because the heat transfers through the sidewall. So yeah, it might not be completely optimal, because you still need like a temperature delta to actually get heat into this heat pipe, right? Like this one has to be warmer than this one on the outer edge in order for this one to actually start, you know, working. But yeah, I don't think it's as big a issue as a lot of people may think it is. So anyway, moving back to the card, which is ultimately the more interesting part of this anyway, since, you know, well, ASUS, I don't think ASUS even does that style of heatsink anymore. So anyway, let's get the VRM heatsinks off. Also, you may have noticed that I do have LPDA VRAM on this card. Luckily on R9 290Xs, the memory controller, the memory bus is so wide that the fact that it doesn't clock very high doesn't matter too much. So this card, I actually managed to, like, I've already modified the BIOS on this card. which of course this card has, you know, old high-end AMD GPU, so it has dual BIOS. The newer ones, well, it looks like AMD is getting rid of the dual BIOS just because, well, they're locking the BIOSes down these days, so you don't need it anymore. But yeah, this does have dual BIOS, and I already have a modified BIOS on there, and the modification, well, actually, I've run 3 different BIOSes on this card at this point. I've run a BIOS which locked all the memory timings to 1375 across the entire, like, all the way from 1375 up. So basically, you know, slightly better memory performance for any given frequency. Then I tried 1000 megahertz strap at all the memory, at all frequencies, and that didn't work. So the 1000 megahertz memory timings are a bit too aggressive. And then I tried 1250, and 1250 actually works really well. Like, it works basically, it hits the same frequencies as 1375. So yeah, that's kind of that. So right now this thing is on 1250 megahertz timings, which is, you know, it works with that and works same frequency range as before. So that's kind of that in terms of the BIOS modding I've done to the card. And yeah, the LPW RAM, like on other cards, I'd say it's more of a problem, but with a 290X, like, it's so, like, it's 512 bits of memory controller. Like, you really don't need a lot of you don't need a lot of clock speed to get a ton of bandwidth from a memory controller like this. Now, there are obviously other trade-offs to the memory controller on here, which is kind of why AMD hasn't done a 512-bit GDDR-based memory controller since, and that's, you have two-phase, like that right there is two-phase memory power for the memory controller on these cards. Now, this is actually kind of, like, this is, you know, it's a matrix, so that's actually kind of excessive, but even, like, the reference card has a really quite substantial memory controller rail because the memory controller pulls a bunch of power. So yeah, we have two-phase VDDCI over there, which is controlled by this chip over here, which is a, it's branded, I don't actually know what it's branded. Anyway, that's a 3567B. ASUS just rebrands it because of course they do. That's running in 6+ two-phase mode, so we have 2 phases over there. Interestingly enough, those are 3598 dual drivers running as like 1 driver each for some reason. I don't know why ASUS decided to do that. It's not particularly cost effective because these chips, like the thing about those chips is that you can run like, you can get a CHL8510, which would do exactly this for... Actually, the CHL8510s might have been more expensive at the time. I guess ASUS just had a surplus of those, so they used those instead. But still, it's just normally you don't see that. Normally, if you have a 3598, it's being either used in doubler mode, or you're having 2 PWM signals shoved into it, and it's running in dual driver mode. But here, it's just single driver on each, which is kind of... Well, no, they could, if they wanted to run it in dual driver mode, they could have used 1. So yeah, I'm still confused by why there's 2 of them. Because it really, like, you don't need to run 2 of them like this, but ASUS decided to, that they're going to run 2 of them, so yeah, not sure why. So 6+2 on the 3567B over here, and then that 6 actually gets doubled by more 3598s. Oh, I know why, it's for the pick-and-place machine. Because they use 3598s for the VCore VRM here. So this is a 12-phase VCore VRM with doublers, which is the 3598s. And then in order to not have a, you know, separate chip belt, essentially, those are also 3598s because you can use, you know, you can do 3598 over here and then over there as well. And you don't have to worry about switching parts for different voltage regulators on the card. If they had CHL8510s everywhere, then like here they'd need 3599s or something, and that would just make the card more complex. Though still, why is there 2 of them? Like that explains why they use 3598s. It doesn't explain why there's 2 of them, because one of them can drive 2 phases. That's even with 2 PWM signal. Yeah, well, weird design decision. So yeah, so we have a 12-phase VCore. For the actual MOSFETs on the 12-phase VCore VRM, we are looking at the 40-amp dual NFETs from Texas Instruments that I keep messing up the name for. I'm going to say they're 87350s, though the 7 and the 3 might be swapped around. I just tend to do that, and I don't know how I still haven't memorized them considering how common they are. But yeah, that's what we're looking at for the actual MOSFETs here. So that's a dual NFET. These are really, really good. Really, really fast. They just can't carry that much current since they do only go up to 40 amps. But that does put our theoretical maximum current throughput for this VCore VRM to 480 amps combined. though that really depends on the ability of this heatsink to cool it at that point. And, well, if you have a Delta fan over it, sure. So, you know, if you shove enough airflow over it, you probably wouldn't even need that heatsink. But for a 290X on LN2, I'm not actually sure that it would even hit that kind of current draw. Though definitely as far as 290Xs go, I think you can get, like, the 290X Lightning just has a better VRM. So, yeah, though the 290X Lightning doesn't have, like, a memory heating system, or, like, this beats, in my opinion, the 290X Lightning on sort of the, random, you know, extra features, like random extras, like the memory heater, the safe mode, the memory heater switch. The other thing is, like, in software, this card actually supports, you can tweak the load line for the vCore VRM, so you can turn the load line on and off, which is not ideal since you don't actually get load line steps, and generally speaking, load line off gives you a whole bunch of extra heat and not necessarily better clocks, and load line on out of the factory is generally configured to give you way too much V-droop, which gives you the opposite issue where, like, the card would run at higher voltages under load, it won't run whatever voltage you're stuck at idle. So you kind of end up between, like, a really awkward situation with the load line slope, where it's either there's no slope, and that's not, like, that just makes everything run hotter and doesn't necessarily, like, it won't, like, it can give you more stability, but it won't be ideal. And then your other load line slope is way too damn much. So that kind of sucks, but it's better than not having any load line slope settings at all. You can also adjust the VRM switching frequency. I've found that actually maxing it out on this card seems to cause way too much heat buildup in this area, at least on the stock air cooler, which basically means that it actually loses stability. Or the VRM is not capable of sustaining 1 megahertz switching frequency, though I'm not entirely sure that if it's 1 megahertz over here or if it's 1 megahertz over there. I suspect it's 1 megahertz over here, which is kind of odd because these... well, I'm not sure if the 3598s can do 1,000. 1 well, it can do 1 megahertz, but these can definitely do 500 kilohertz. So, yeah. I'm not sure, like, why that would be, but so far I've basically had most success with running at 900 kilohertz. I tried to whack it up to 1 megahertz a few times, and the card doesn't seem to like that, or it was just me messing with other settings, so that screwing that over as well. Now, the other cool feature that this card has in terms of software controls is that your 0.95 volts rail and 1.8 volts rail is actually accessible through software. In fact, you actually have software voltage control for everything. So 0.95 volts, which is the, that's essentially cold boot bug, well, no, not cold boot bug, but cold bug removal for 290Xs, and display driver issue removal as well. So 290Xs have a habit of, like, dropping display output if you have very high core voltage at very low temperatures, which is really annoying because the benchmark will be running, there just won't be any output getting rendered. And the 0.95 volts rail can actually solve that if you just raise it. And on, say, 290X Lightnings, you actually, as far as I'm aware, you need to do a hard mod to get control of that rail, whereas on these cards, if you use GPU tweak in all its horrible, horrible crashy glory, you actually get manual control over that rail, which is really cool. 1.8 volts also has control, though I don't think it necessarily helps with anything. But still, just another rail to be able to adjust, so certainly won't complain about that. Like, on the off chance that it does fix up something, you don't have to volt mod it. VDDCI is, of course, controllable because that's on the 3567B. vCore is controllable. And memory voltage is also controllable. And all of these are actually limited unless you, mess with the various solder pads on the back. So that's how ASUS sort of stops, people who don't know what they're doing from blowing up the card with way too much voltage. So normally the card's limited to, like, 1.41 volts vCore, 1.63 volts memory voltage, which is actually on the safe side as far as I'm concerned. On GDDR5, you can normally run like 1.7, even 1.75 volts, and it's not really an issue. 0.95 volts rail is limited to just over a volt. 1.8 volts, I don't know, because it doesn't do anything, so I haven't even checked where it goes. And VDDCI is limited, I don't know to what, because GPU Tweak for some reason decided that it's not going to give me access to it. So yeah, also that rail generally doesn't do anything, so I've not really been too fussed about finding a piece of software to control it. Though I'm sure Afterburner should pick it up. So that covers the rails we have. Oh, and for both VDDCI and VMEM, we have 3056 QM3056 UBIC semiconductor low side MOSFETs and 3054 like QM3054 high side MOSFETs, which is basically standard ASUS minor rail MOSFETs, and those do a fine job. Like neither of those is that power hungry. I mean, well, this one's somewhat, but this one's more so than the memory rail, but they're like it's more than enough, and they are both two-phase, which is a upgrade from what you'd get on like a reference card where each of those is actually a single phase. What else was there that I wanted to cover? Oh yeah, the other thing that the memory heater does is, did we talk about the memory heater? I mean, partially it's for memory chips that don't like cold. The other benefit to the memory heater is that if you have memory chips that don't necessarily, like, let's say they don't scale with cold, so there's no reason to keep them cold, the memory heater does mean that, like, this entire area of the card essentially ends up being, the end of the frost. So the frost won't, like, spread to your display outputs, it won't spread all the way to your VCore VRM, and it won't go all over the card, so you don't have to do as much insulation. And if your insulation's a bit dodgy, it also puts less stress on it because there's going to be less condensation buildup, because it's basically going to be constrained to just around the GPU core. Now, if you have memory chips that actually benefit from the cold, then it doesn't really do anything for you because you're not going to be using it because the memory chips prefer being colder rather than warmer. Anyway, let's keep disassembling this card. I'm kind of sad that this brace right here isn't like LN2 pot compatible. It just goes right through the section where the LN2 pot would go. Because that's nice to just add rigidity to the card. But the backplate is. So we can keep the backplate while removing the brace. So that's still, well, I'm actually not sure I'll use the backplate because it might interfere with the mounting hardware a bit. But it's always an option. Like if you can, I personally prefer to keep the backplates just because it reduces how much stress like it makes it harder to bend the PCB when working with it. Because LN2 pots are ridiculously heavy, and they tend to, well, it puts a lot of strain on the card physically. So let's get that out. So the reason why we're going to the back of the card is I'm still considering modding this card a bit. Like, I'm noticing that, say, this right here, it looks like ASUS wanted a bulk capacitor over there for memory power, and then they kind of decided against that. So I may or may not be... Actually, I probably will be installing that. So I will be adding that on there. But I also want to check out the back of the card, because I'm thinking, well, if they haven't done, everything on the front, they've probably not done everything on the back. So, yeah, they've really not done anything too elaborate on the back of the card here. So, we can see there's a bulk cap missing there, and there, and there. Well, actually, yeah, those are capacitors. Those are marked out for capacitors, aren't they? Yeah, they are. That's an odd package. Anyway, so yeah, I will probably be adding extra capacitors to the card, just to try get the memory to clock a little bit better. I'm not sure... Stacking anything on the core is going to be a pain. Looking at that right there. Actually, it might not... Well, depending on how these are how these are laid out, it might not be that bad. Because they might be like one strip of V-core, one strip of ground, and then... Yeah, that'd be relatively easy to actually work with. So, yeah, and also my concern with like mounting LN2 pots is I'm not sure, because... These aren't just straight holes. They actually, like, when you normally mount the card, the mounting hardware, like the card has spring-loaded screws for the stock heatsink, so those actually stop against the backplate. They don't stop against the PCB of the card, so I'm kind of wondering if that wouldn't cause issues with LN2 pots potentially. Because those obviously don't normally come with backplates at all. Anyway, I mean, I normally don't run backplates because most of my cards are reference anyway, so wouldn't be a huge difference. It was just like, well, it'd be nice to have the ability to run the backplate for once. But yeah. Yeah, this looks really, really quite standard for a 290X. So probably going to add capacitors like 1 or 2 per memory chip everywhere. Then try add some bulk. Just because memory chips far away from the memory VRM will very likely have lower voltage. Actually, this would be a perfect candidate to check that. Because 290Xs, with how many memory chips they have, they pull a lot of memory power. So it would be rather interesting to see like what voltage we have over there versus what we have over there. Because it's probably going to be a tad lower. Also depends on how much current the memory is actually pulling. But yeah, we'll see if I can get the memory to clock any higher. Because theoretically, like this is a really hard memory setup to like power, because there's just so much freaking GDDR5 on here. And I mean, I've had success with cap modding other, GPUs, though most of the time it's NVIDIA cards where it's like you add a bunch of capacitors to the memory rail and suddenly it picks up a bunch of speed. But yeah, we'll see if this one does. Because the thing is, like, ASUS basically, like, this core section looks basically like a stock R9 290X. That doesn't look like they really bothered to do much of anything in that area. Though, maybe, like, I'd have to compare it some more, but, yeah, this looks pretty standard. And then on the actual vCore, like, on the VRMs themselves, they also aren't really doing anything elaborate, right? Like, this is pretty bog standard ASUS. I mean, here they even didn't bother with the... Over here, they didn't even bother with the multi-layer ceramics, which they were like, oh yeah, we're totally going to put those on there. And then they were like, nope. Yeah, so we can actually see, like, you have those relatively large multi-layer ceramics over by that chip. And then not by this one, and not by that one, not by that one. Then we have, like, that, which I assume that was on memory. That's on memory power. Which was, like, that was supposed to be, like, a localized reservoir for chips far away from the bulk capacitance over here. So yeah, I will definitely be adding capacitors to this. No need for volt mods, luckily, because we have all the, well, GPU tweak should do everything once we enable the little pads that we need to short. Yeah, it should be an interesting card to keep messing with, because so far on air cooling it's actually been, like, on the stock air cooler, this has been actually really good. So this thing does like 1220 core at 1.37 volts and with droop enabled. So I've not yet tried disabling the V-droop just because I don't know why. I've just, you need to test everything. So far I've just been testing with droop enabled, and it does like 1220 at 1.37 volts, which is really, really good as far as my experience with 290Xs and 290s goes, because I mean, I had cards where you wouldn't do... Like, I think my previous 290X that actually worked, because I have a pile of them that doesn't work. But if we go by 290Xs that do actually work, the last 290X I had that I've tested, that I remember using, was like 1230 on an AIO at like 1.45 volts. Like, it was terrible compared to this thing. Like, this thing is, 70 millivolts better on far inferior cooling for fire strikes. So... yeah, this is a lot better than my last 290X in the core department. In the memory department, it's roughly the same. I'm hitting like 6400 megahertz, and that's with the 1250 megahertz timing strap. So yeah, we'll see if I can maybe push it to do 6600, 6500 megahertz memory timing, 6500, 6600 memory clock with the 1250 timings. Maybe even 7 gigahertz. Like, that'd be kind of ridiculous, but yeah, like, so far it's been a good card for air cooling. So yeah, I'm pretty happy with it. So yeah, that is the R9 290X Matrix. One of the... Actually, it's not really the last Matrix. Like, the last real Matrix was like the 980 Ti Matrix. Yeah, 980 Ti Matrix was like the last real Matrix card. And the new Matrix card should have been named after some random water deity. I understand that they didn't want to name the new Matrix card after the Poseidon cards, because the Poseidon cards are like a full custom water block integrated into an air cooler. Well, a shoddy well, a not so great custom water block integrated into a not so great air cooler, right? Because you tried to do both and neither of them works out that well. But we're just gonna reassemble it. But this is definitely, you know, I like this card. Out of a lot of the cards in my GPU collection, this is one that, you know, we have like a special like extreme overclocking edition. So I'm happy that it's a matrix and not just some random reference card that doesn't like. That's like, I think the worst when you have a reference card that's really good, because it's just like, oh no. I wish it, like, imagine how much better it would be if it wasn't a reference card. But yeah. So far, I've just really enjoyed this card. Can't wait to mess with it some more, and also mod it, of course. So yeah, that's it for the video. Thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with Actually Hardcore Overclocking, I have a Patreon and t-shirts and other stuff you can buy on Teespring. There's links to both the Patreon and Teespring down in the description below. Those help out immensely with, you know, doing things like buying 290Xs off of eBay. So, yeah. And you'll, well, will you probably get a live stream with this card. Not necessarily soon, though, because at this point I'm kind of thinking of putting it back in its box and then messing around with, like, I have another 290X, which is a Vapor X card that I need to mess with. Anyway, I should just hit the stop button at this point, shouldn't I? Because I have just done the outro. Where'd the mouse go? There. Oh, nice. Stop button, here we go. Goodbye, guys.